cardinality of functions. If n of a equal to p and n of b equal to q, then the total number of functions that exist between a and b is q power p. This formula gives number of functions that are possible between a and b. If set a equal to 1, 2, 3, 4 and b equal to 5, 7, 9, 11, 13, 15, then total number of functions exist or possible equal to 6 power 4 equal to 1296. Simple example. Set a equal to 1, 2, 3. Set b equal to a, b. Possible functions are 1a, 2a, 3a. This is one function. All functions should have 3 ordered pairs. Then 1a, 2a, 3b. 1a, 2b, 3a. 1a, 2b, 3b. 1, b, 2, a, 3, a. 1, b, 2, a, 3, b. Up to this. So we have 8 functions. And as per the cardinality principle, q is 2, p is 3. So 2 power 3, 8 functions are possible. Same thing in map form. This is one function. All the elements in domain paired with a. Second function. 1 and 2 mapped to a, 3 mapped to b. Then third, 1 and 3 mapped to a, 2 mapped to b. Finally, all 3 elements in domain mapped to b. Write 3 functions from set x to y where x equal to 1, 2, 3, 4 and y equal to a, b, c. 81 functions possible as per cardinality. However, 3 are given. 1a, 2b, 3c, 4c. Then f2 equal to 1a, 2a, 3c, 4c. 1 and 2 have the same image, 3 and 4 have the same image. F3, 1, c, 2, b, 3, a, 4, a. You can write your own functions. Bijection, encrypting data and again getting the original data back. A is coded as the second letter from it. That is second letter following A. Then B is coded as second letter following B, which is D, and so on. For example, base will be coded as DCUG. Here each letter replaced by second letter following it. Now to decrypt or get back the original data, we need to replace each letter in this word by the second letter preceding each letter. How is bijection encrypted using the above method? So the word bijection I only occurring once. The decrypted letters are D, K, L, G, E, V, Q, P. Coming to the function concept, bijection. A function is given in arrow diagram. Is the following function a bijection? Here each and every letter in the domain having one image, and in the codomain all the elements are paired. Hence this is 1 to 1 and on to. Therefore this is a bijection. Similar function shown in arrow diagram. Is this also a bijection? Same bijection. The domain contains A, B, C, D, K, L, G, E, V, Q, P, R. This is not a bijection. This is 1 to 1 but not on to. Hence not a bijection. Example 1.15. Let f be a function f maps n to n be defined by f of x equal to 3x plus 2 x belonging to n. First subdivision, find the images of 1, 2, 3. Solution, image of 1 will be equal to 3 into 1 plus 2 equal to 3 plus 2 5. Image of 2 is 8. Similarly, image of 3 will be 11. Hence, the images of 1, 2, 3 are 5, 8, 11 respectively. Now, second subdivision, find the pre-images of 29 and 53. Given f equal to 3x plus 2, x will be equal to f minus 2 by 3. For the f value, x is given, which is the pre-image. Therefore, pre-image of 29 equal to 29 minus 2 by 3. 27 by 3 equal to 9. Pre-image of 53 equal to 17. Same question continued. Identify the type of function. The codomain of f is n. The range of f is 5, 8, 11 and so on is a proper subset of n. That is, many elements in codomain do not have a pre-image. This is an one-to-one and into function, not an onto function. Example 1.16. Forensic scientists can determine the height in centimeters of a person based on the length of their thigh bone. They usually do so using the function h of b equal to 2.47b plus 54.10, where b is the length of the thigh bone. Check if the function is 1 to 1. So, forensic scientists will get lot of samples, human body samples for investigation. Sometimes they will not get the whole body, they may get simply one thigh bone. Using the thigh bone, they will calculate the height of the body using this relation. Height of the body as a function of thigh bone. To check if the function h is 1 to 1, we assume that for two distinct arguments b1 and b2, h has the same value. Therefore, h of b1 equal to h of b2. 2.47 into b1 plus 54.10 equal to 2.47 b2 plus 54.10. Now, both the side 54.10 is there, therefore they can be cancelled. Then 2.47 b1 equal to 2.47 b2. Therefore, b1 equal to b2. This is contradicting the original assumption. Since f of b1 equal to f of b2 implies b1 equal to b2, this is an one-to-one function. Same question continued, subdivision 2. Here, length of the thigh bone is given 50 centimeter equal to b. Height of the person therefore equal to 2.47 into b, that is 50 centimeter plus 54.10. Multiplying we get 123.5 plus 54.10, finally coming to 177.6 centimeter. Third subdivision, height of a person is given as 147.96 centimeters. Then his length of thigh bone is, now in the function height of the person h equal to 2.47b plus 54.10, h is given, b is to be found out. This equation now rearranged, 2.47b equal to h minus 54.10. Therefore, b equal to h minus 54.10 by 2.47. Then h is 147.96 minus 54.10 by 2.47. On simplification, it comes out to be 38 centimeter. Function types in map form. First, 1 to 1. Each element in domain one image, not a many to one function. It is also called injection. Codomain will have some elements unpaired. One image, one pre-image. Then many to one. Many pre-images to one image. Codomain, some elements may be unpaired. Onto. also called surjection. Codomain all elements paired. Codomain equal to range. 1 to 1 and on to is bijection. Argument and images. You know very well, domain contains arguments or pre-images. Codomain contains images, also it contains range. What are all the function types? What is bijection, onto, one to one, etc. 1 to 1. Distinct elements in domain have distinct images in codomain. This is also called injection. Some in codomain may be unpaired. Many to one. Two or more elements have same image. Some elements in domain may be unpaired. Into. At least one element in codomain does not have a pre-image in domain or not an image of any element in domain. Bijection onto one to one. What are these in the function context? Onto range of functions equal to codomain. No element in codomain is unpaired. All elements in codomain are images of some element in domain. That is also surjection. In right side set or codomain, in the arrow diagram, nothing is unpaired. 1 to 1 and on to is bijection. All function types in a Venn diagram form. Two sets. Left side is for on to function types. Right side for into function types. In on to bijection, surjection, 1 to 1, many to 1. However, fully paired codomain. Now coming to into functions in which some elements are unpaired in codomain. So this is partially paired codomain. Injection, again 1 to 1, many to 1. We can see 1 to 1 and many to 1 are coming under on to category as well as into category. Same Venn diagram, category changed. There are two categories, 1 to 1 type of functions, then many to 1 type of functions. Here distinct images to each element in domain. Here shared images. Two or more elements in domain share the same image in codomain. So in distinct images category, that is 1 to 1 function, bijection, injection. Also on to, that is fully paired codomain, into partially paired codomain. Coming to many to one function are shared images type functions. Surjection, then onto, into. Here onto and into belong to both 1 to 1 and many to 1 types. 1 to 1, many to 1, onto and into functions are shown in arrow diagram. You can leisurely see this. Then bijection, injection, surjection are shown in arrow diagrams. These are given for the learners to get a better appreciation. Types of functions given in a tabular form. Again, whatever shown in the diagrams, the tabular form. What are junctions? Injection, surjection, bijection. An 1 to 1 function is called injection. An on to function is called surjection. Both 1 to 1 and on to is called bijection. Range is equal to B, then it is on to function. B is codomain. Sum in codomain. Unpaired, then into 1 to 1, many to 1. We can graphically represent on to functions only. Identifying the graphs of linear, quadratic, cubic and reciprocal functions. Any function of the form mx plus c or ax plus b is linear function. The function graph will be a straight line. For example, f of x equal to 2x plus 3 is shown in the graph. If we mark the ordered pairs as points in the graph and join them, we will get a straight line. Quadratic function f of x equal to x square is shown in this diagram. This is in the parabola shape. Then f of x equal to minus x square, again parabola shape, but pointing downwards. F of x equal to x square is holding type. F of x equal to minus x square is pouring type. Then cubic function. This is f of x equal to x cube. Continuation of identifying the graphs of linear, quadratic, cubic and reciprocal functions. A special type of linear function, that is identity function, f of x equal to x. It is shown, it passes through the origin. Additive inverse function, f of x equal to minus x. The function curve is shown here. This is negative slope. For increasing value of x, the function curve is going downwards. Function value is decreasing. In identity function f of x equal to x, the slope is positive. For increasing x value, function value is increasing. Reciprocal function. This is f of x equal to 1 by x. Constant function f of x equal to some constant. Here f of x equal to 3 is shown. For whatever be the value of x, the function will be equal to 3. This is also a linear function. Modulus function or absolute valued function. F of x equal to mod x is the modulus function. It is defined as f of x equal to x when x greater than 0. F of x equal to minus x when x less than 0. It is shown in the graph. If you like this video, please subscribe.